Assalamu alaikum wa rahmatullah. So, I'm really sorry that I couldn't post this video on a scheduled time. I'm really struggling with the Ramadan schedule and the timing. So today's topic is we'll be discussing about two topics. Um, one is synonym and the other one is cardinality. Okay, so I think you already know about this topic. So uh, I'll give a brief description of these two topics, and um, I'll give two tasks based on these two topics. Okay, so first of all, what is a synonym in a database? Right. So what is a synonym in a database? So synonyms are basically a layers that gives abstraction. Okay, so synonyms are basically layers of database um, that creates abstraction. Okay, allowing us to use local names uh, for remote tables, views, procedures, functions, etc. For example, suppose you have server 1. Okay, you have server 1, and let's say you have a schema. That schema name is, let's say, ABC. So this is one schema, and let's say in that schema you have a table called employee. Okay, let's say this is EMP table. Now if you want to perform some query operation remotely, let's say you are in system now and you want to perform some operation on this table, then what you need to do is you have to uh, refer to that table with this command server1.abc.emp, right? So it exposes everything: server name, schema name, table name. It exposes everything to the end user. Okay, so instead you can use a synonym, and you can create a synonym like create public or private. Let's say we are using a public synonym. Create public synonym. Public synonym. Let's say EMP table. EMP table for this table. So server1 dot abc dot emp. Okay, now you can use this this synonym to actually see the data of the table, access the data of the table, okay, manipulate the data in the table. Okay, so it gives the advantages of abstraction, ease of change, and scalability. Okay, so later, let's say you want to change the server name or the schema or the table name. Okay, just you have to change the synonym alone, and there is no need for like you do search all and replace them. Okay, so this comes really handy whenever you want to perform remote operation on a particular table or a function, or yeah. So let's say there is one function and you want to one function in the main server, and like there are many mini servers all around the world, and they want to use the instance of that server remotely. So synonym can come really handy in those processes. Okay, so this is one example. So I don't think I need to show you the SQL operations, because I have already written the synonym syntax here. So I have given a tricky question regarding this synonym, so you can use that. You can use your common sense to solve that question. So basically what you have to do is you have to create a user you have to create a table in that user. Then from the system, you have to create a synonym for that table. Then by creating another user, let's say this is user 1 and this is user 2, you have to access that synonym. Okay, so this is your task. So this is the um, mm, this is your the concept of synonym. I think it clarifies everything. Now, cardinality. So cardinality, you have already worked with this with these cardinality problems in your DBMS course. So in data models, cardinality is basically the relationship between two models. Okay, so relationship can be of different types. Okay, there is one-to-one relationship, one-to-many relationship, many-to-one relationship, many-to-many relationship. This normally this four kind of relationship is used. Okay, so um, how do you implement one-to-one relationship? Okay, but before that, let's give a better example of cardinality. So one example of cardinality can be, okay, let's define the degree of relationship. So there can be three types of relationship. So um, the first one is one-to-one. Then there can be one-to-many, one-to-many. Then there is many-to-many. Oh, there can be another type of relationship, and that can be many-to-one. So what is an example of one-to-one relationship? Okay, let's say um, an employee is working for an organization. Okay, and for that employee, a vehicle is allotted for that particular employee, with the condition that that vehicle will be solely driven by that employee. No one else um, would drive that vehicle. Okay, so is assigned to company vehicle. Okay, so this is one-to-one relationship. Okay, so um, how do you actually implement this one-to-one relationship? Let's say um, yeah, another example can be, well, let's say you have one student table in your database and you have one address table in the database. Okay, so this address table actually contains the address of all the students, all the faculty members, all the staffs. Okay, now let's say this student table has these entries: ID, then name, then address ID, Okay, now um, this address table would also contain um, another address ID. Let's say this is address ID, which will refer to that. Actually, I do not need this address ID. Let's say this is not address ID. Okay, let's say this is not address ID. Let's say this is CGPA. Okay, and this address, let's say this address contains city, zip code, and student ID. Okay, student ID, which would refer to this ID, okay, as a foreign key. Okay, so the constraint here should be every ID should be unique in this case. That's where we can actually establish one-to-one relationship in this case. Okay, and how do you actually write the unique constant? So the unique constant is basically written as, let's say, this student ID number references this student table and this ID column, and the constraint is, let's say, the constraint name is, let's say, any constant C1, and it should be unique. Okay, should be unique. What should be unique? The student ID. Okay, the student ID should be unique. So but with this syntax you can actually establish a one-to-one relationship with student table and address table. Okay, now how do you actually establish a one-to-many relationship? Let's say two students actually shares the same address. Okay, or let's say no, let's say one student has two homes. Okay, let's say his one is his parents' house and another one is his grandparents' house, and he or she actually lives both of the houses. Okay, lives in both of the houses. So in that case, though this is a complex scenario, but let's say it can happen. Okay, so in that case, or there can be another example, let's say teachers and classes. So one teacher can actually take many of the classes. Okay, so let's say teacher and let's say class. So let's say this teacher has teacher ID and let's say name, and this class has name and this teacher ID or TID. So in this case, one class can be taken as this particular teacher can take many of the classes, right? They can take many classes or many courses. So in that case, this can be a one-to-many relationship. So how do you implement a one-to-many relationship? So you can simply use this keyword. Let's say TID number references the teacher table, and this unique constant should not be there. Okay, this unique constant should not be there in that case. Okay, and the last one that we'll be talking about is a junction many-to-many relationship. So many-to-many relationship, and in that case you can use a junction table. Okay, a junction table. For example, actually many of the students many of the students takes many of the classes, right? Many of the students can like attend in many of the classes. Okay, so let's say you have student table. So you have SID, you have name, and you have classes table. So this should be class ID and let's say name. Now to relate these two tables, you can use another table, student class table, which would contain only the SID and the CID. Okay, in the junction table. So this is the junction table, and that's how you can establish a many-to-many relationship. Why there is a many-to-many relationship in this case? Because one student can attend in many of the classes, and one of the class is attended by a lot of students, right? So that's why you need another table to um, to accommodate all this data, all this information, that which students will take which classes and which classes are attended by which students, right? So yeah, so this is the student class relation. So in case of many-to-many relationship, you need a third table to actually define that many-to-many relationship. Okay, so I think you already know these concepts in your DBMS course. Okay, so that's why actually I did not give you any example. So if needed, I can actually discuss it in the next classes, inshallah. So an easy problem, an easy problem would be given on this cardinality topic as well. So you'll have 1 week to complete this. Okay. So yeah, see you in the next class, inshallah. Assalamu alaikum.